Here's how you deal with linear equations having fractions. I'll give you two methods. One method is first you move the 7 over 8 to the other side, and the first method uses the fact that when you add or subtract fractions, you need common denominators. So we're just using the regular way to handle fractions. Now, because fractions require common denominators, so let me multiply the first one top and bottom by 8, and the second one top and bottom by 3. And the result of this is now you get 8 over 24, because 8 times 3 is 24. 7 times 3 is 21 over 24. And then 8 minus 21 would be negative 13. And finally, you divide by 3. And remember, when you divide something, that's like multiplying by 1/3 both sides. And when you have 1/3 both sides, that 3 gets multiplied to the denominator. So you end up with 13 over 24 times 3, which is 72. So that's the answer. Now let me give you the second method, which in most cases is better. So I really want you to learn this one. The way we're going to handle equations with fractions is basically the idea is that we don't like fractions. Okay, we want to get rid of any fractions if there is any. And although when it's a direct calculation question like what is 1/3 minus 7 over 8, we can't do anything about it. We have to deal with it. But if it's an equation or even an inequality, there's a way to get around it by getting rid of the denominators. Because if you have a denominator and you get rid of it, that means it's no longer a fraction, right? So I chose to multiply by 8 because if I multiply by 8, this is going to cancel away. So this is no longer a fraction. Pretty neat, right? So that's the idea. I still have this 3, so I better multiply by 3 as well. And then 3 times 8 times 3 gives you what? It gives you 72. 3 times 8 is 24. 24 times 3 is 72. 7 times 3 is 21. And 3 cancels and gives you 8. Now you subtract 8 minus 21, which is negative 13, and then finally divide by 72, and you get negative 13 over 72. And usually this gives you a quicker answer. However, there are cases when it's easier to not do the multiplication by 11. So for this one, although times 11 to everything would make this fraction be a non-fraction, it'll just turn it to 9. This one is simple enough that it's better to just solve as it is. So I would add 5x both sides, and the result is that you just have 2x on the left side, right? Then dividing by 2 gets multiplied by the denominator, so you get x equals to 9 over 22. So this is a case where it's simple enough that you would just do that. Okay. All right, so here's our last example, which can be done in both ways, but I do still have something to talk about in this case because you're dividing by a fraction. So let's try that. Subtract 7 over 9 to the other side. And then when you divide by fraction, you get a complex fraction, right? You have to change this into simple fraction. In that case, you either have to use the keep, change, flip, right? Or which means it's the same as negative 7 over 9. You keep the top, and then division becomes multiplication, and you flip the fraction, which is 11 over 7. And then 7 cancels, so you get negative 11 over 9. Or another way to do this would be to, rather than thinking of this as dividing by the fraction, think of it like multiplying by the reciprocal. So you multiply 11 over 7, and you multiply 11 over 7 both sides, and they are going to cancel, these are going to cancel, and you get x equals to this side, but 7 and 7 also cancel, so you get negative 11 over 9. So this is an easier way to think about it.